To ENT student, now we are going to discuss physiology of perception of smell sensation. The objectives of this session are: first one, site of olfaction, olfactory pathway, physiology of olfaction, applied aspects. Sense of smell, microosmotic, sense of smell well developed to give warning of environment. Microosmotics, in human it is less developed. Site of olfaction, specialized receptors located on free nerve endings of olfactory nerve located in olfactory mucosa. Here we can see olfactory mucosa beneath the olfactory epithelium. Olfactory mucosa, location on upper one third of nasal mucosa. It is located on roof of nasal cavity and on nasal septum and superior nasal concha on lateral wall. It is covered by mucus layer. Characteristics feature of olfactory receptors: only sensory neurons close to the external environment. It has short lifespan of 60 days and gets replaced by proliferation of basal cells. Nerve supply of olfactory mucosa. Olfactory mucosa innervated by olfactory neurons. Generally, sensory nerve supplying olfactory mucosa is trigeminal nerve. Olfactory pathway. It involves olfactory nerves, olfactory bulb, olfactory tract, anterior olfactory nucleus, olfactory stria, and olfactory cortex. This is the olfactory pathway. It starts from the olfactory receptor cells going to olfactory nerve, then olfactory bulb, then olfactory tract. From the olfactory tract, it goes to medial olfactory area and lateral olfactory area, thus having the sensation of smell. Olfactory nerves, 15 to 20 olfactory nerve filaments forms bipolar neurons. Pierce cribriform plate of ethmoid bone to reach olfactory bulb. Reaching olfactory bulb, it has flattened strip of grey matter on cribriform plate which receives neurons. Points to points representation of olfactory mucosa on bulb. There are three types of cells: mitral cells, tufted cells, and interneurons. Cells in olfactory bulb. Axons of olfactory neurons terminate on dendrites of mitral cells and tufted cells to form glomerular masses, that is olfactory glomeruli. Axons of mitral and tufted cells runs in olfactory tract after leaving olfactory bulb. Granular and periglomerular cells are inhibitory neurons. Coming to the olfactory tract, it lies in the olfactory sulcus and proceeds backwards and divide into lateral, medial, and intermediate stria. Olfactory trigone, flattened part of olfactory tract. Anterior olfactory nucleus, made of scattered neurons in olfactory tract, receives afferent from bulb and send efferent to anterior commissure to excite inhibitory neurons on opposite bulb. Olfactory stria, lateral. Synapse in prim olfactory receiving area includes prepiriform cortex. Medial, give projections to amygdaloid nucleus and cortex of basal brain. Intermediate, terminate in olfactory tubercle. Olfactory cortex includes anterior olfactory nucleus, prepiriform cortex, olfactory tubercle, and amygdala. These are parts of limbic system. So coming to the physiology of olfaction, odoriferous stimuli are enters then nasal cavity while breathing, then it reaches lower part of nasal cavity and by eddy currents reaches olfactory mucosa. Odorant molecules must dissolve in mucous layer before receptors. Characteristics feature of odorant molecules. To be effective, odorant molecules must be volatile, water soluble, lipid soluble. Types of odorant stimuli: 50 primary smell sensations are there. Can smell over 10,000 different odorant molecules. Common odors: aromatic, fragrant, ethereal, garlic, burning, nauseating, goat, repulsive. So transformation of odorant information to the olfactory cortex and neocortex involves this pathway. From olfactory bulb it goes to olfactory cortex, that is piriform cortex, amygdala, olfactory tubercle and part of entorhinal cortex, then it goes to frontal cortex. These are the applied aspects. Ansomia and hyposmia are total loss and decreased sensitivity. It caused due to injuries, intracranial lesions, nasal obstructions, atrophic rhinitis, old age, Kallmann syndromes. And pyrosmia or dysosmia is distortion or perversion of smell. Thank you.